Hello, this is a video for a lecture series on 7th grade math geometry. Excluding the part on circles, there's a separate series about that. We're going to be focusing on types of angles and then areas of two-dimensional figures and then the surface area and volume of certain prisms. Now, on this first video, I want to focus on angles. So there are many types of angles that you have to learn as a 7th grader. First one is this idea of angle, though. We have to talk about what that is. So it's basically a shape that's formed by two rays or two sides, right? And they meet at a common point. And the angle itself is the kind of the space between them. Now, it is usually symbolized using the letters that mark the edges of those rays and the vertex. The vertex is the point where they actually meet, and the sides or rays are the points that go away from it, right? Now, the way you do it is I usually go in alphabetical order and starting from one of the rays and then list the vertex and then the other ray. And you make this little symbol next to it, little, almost like a bigger than symbol or a smaller than symbol. So it's like the angle between A, O, and B. That's what that's saying. So that symbol that looks like a little acute angle, right, is essentially the angle symbol. Let me try to get close to so I can pinpoint what I'm actually talking about. Talking about that symbol right there, right? So representing AOB. Now, like I said, the arms or sides are the two rays that join to form up the angle, and the vertex is the point that connects them. Now, we represent angles in two different ways, with radians or with degrees. And in middle school math, you're only going to use degrees. And in degrees are the unit of measurement for angles where you divide a circle, an entire circle, in 360 equal parts, right? And so the first quarter of that is from 0 to 90. Now you go counterclockwise to count these angles. So by the time you get all the way up here, you add a 180, 90 more, you're at 270, 90 more, you're at 360. So each quadrant here, it's made of 90 degrees. And you get a general idea of these common angles that show up. Look how steep 75 degree is. 60 is a little less. 45 right between 90 and 0. 30 and 15, right? So this gives you an idea of the size of these degrees. All right, now, if you have an angle that is not bigger than 90 degrees, it's just somewhere between 0 and 90, we call those kinds of angles acute. Acute angles are less than 90. Right angles are exactly at 90. Obtuse angles are past 90, but less than 180. A straight angle is one that measures exactly 180, and that's because it basically is the angle around a straight line, right? And then you have the reflex angle, which is one that past 180, but less than 360. By the time you get to 360, you just have a full circle, and that's what that will be called. Now, you also have this term referred to as adjacent angles, and those are any angles that actually share a vertex and one side. So if you had, for example, a setup like this, where you have three angles, over here you have angle A, over here you have angle B, and then the last one, angle C. Now you could say that A and B are adjacent, or that B and C are adjacent, but you cannot say that A and C are adjacent because though they share a vertex, they do not share a side. So basically, I just think of them as angles which are touching each other. Now, there are special types of adjacent angles that we often talk about. First one is this idea of complementary angles. And those are angles that when added together come out to exactly 9 degrees or to a right angle, which is what 90 degree is, right? So complementary angles add to 90 or are exactly a right angle when put together. Meanwhile, supplementary angles are those that add together to make a straight angle or 180 degrees. And the last type of angle that I have to talk about is this idea of a vertical angle. Now, a vertical angle is an angle that shares a vertex, but it's on opposite sides of another angle with which it shares its vertex on a set of intersecting lines. So you have two intersecting lines, a vertex in the middle, and the angles which are opposite to each other are going to be equal to each other. By the way, technically, and I'll show you this again in a second, these two angles here will also be considered vertical angles. So there's always two pairs when you have a set of vertical angles. This pair is the same as this, right? So this makes a pair, and then the little ones here will make a pair. Now, this happens to be two obtuse angles pairing up and two acute angles pairing up, if that's the case. Another thing that's interesting too, when you have a supplementary angle, you always have at least one obtuse and one acute adding up together. All right, so those are the terms. Let's go through it one more time with a few more examples, and hopefully that'll make it clear. So here's an example of complementary angles that add up to 90. So 52 and 38, when put together, make 90. So they are paired together to make exactly a right angle or 90 degrees, and we call them complementary because of that, right? So if you need a way to remember this, I just think of it as when I go out to dinner and they made the drinks complimentary, and I think of this as the table with the drink sitting on top of it. So the drink was complimentary. It adds up to 90 degrees. I don't know. It helped me when I was in school. Supplementary angles, on the other hand, is when they add up to 180. So here's an example. 128 and 52 make supplementary angles, right? So let's look at more examples of supplementary and complementary. Here's 140 plus 40, making the 180. So straight angle, therefore supplementary. 25 and 65 added together to make complementary angles. So there you go. This idea of size, right? Obtuse are the big ones, but less than the straights. Here's a straight one, and here's an acute one, which is cute and tiny and small. The right angle, which is the one that makes this 90-degree mark. And finally, but not least, you have the reflex angles, which are the ones which are bigger than 180, but less than 360, which would make a full circle. Finally, the last concept was this idea, or the two last concepts, this idea of adjacent angles is any two angles that share a vertex and a side. So complementary and supplementary angles will automatically be adjacent angles. Be careful, by the way, just because it looks like it makes a right angle, it might not. This is 20 plus 80, which is 100. So these are not complementary here, right? So be careful with that. Lastly, we have the idea of vertical angles, right, which are two paired up angles across intersecting lines, and they're on the opposite sides of the vertex. So the x's are the same and the y's are the same. And here's an example of that. It's kind of tiny, so let's get closer. This is 54 degrees here and 54 degrees here, which means this is going to be, here's another interesting thing. Every time you have a vertical angle, you're always going to have an acute and an obtuse adding together across a set of 180 degrees, right? So if you look at it this way, that actually makes 180 degrees. So if this right here is 54, whatever you put here, which is 126, has to add up to the rest of 180. So vertical angles are also made up of a set of two sets, actually, of supplementary angles, right? And you can actually use that to figure out missing angles, right? Because if you know that this one is 54, you can figure out this is 126. Then you know this is also 126, and you know that this is also 54 because of vertical angles. All right, so that is it for our discussion about angles and angle types. In a different video, I'm going to do some practice problems with this when I do the workshop video. And on the next video of this series, I'm going to talk about area and volume and surface area. So I'll see you guys there.